Now we move on to weir flow. So weir is a, like, the orifice is for regulating flow through a tank, right? This is the orifice. A weir is used for regulating flow through a channel. It can be a river or something. So how do I draw this? So this is a river, any channel. This is a riverbed. To control its flow, you put a weir on it with a specific opening size. So that by controlling the length and width of the weir, you can control the velocity, the flow rate coming out of here. It's used for irrigation. It's used for in dams. It's used in a lot of things. Okay, so let's go to weir flow. So let me see if I can draw it nicely. Okay. This is the weir. Okay. So, and this is the river channel. So when it approaches the weir, it will, this thing decreases a little because the velocity in here is very less compared to the velocity out there. So the velocity is very high. To preserve the Bernoulli equation, the elevation becomes low. Because in both the cases, like if you think here and here, take these 2 points. See, everywhere Bernoulli equation is valid. Here and here, take point here, point 2. The velocity out here, V1, is much less than V2. The pressure head in here is equal to pressure head in here because both are P atmosphere plus the weight of the water column here, the weight of the water column. Okay, sorry, the pressure head is different because that's why. The elevation head, if you take this to be the datum, the elevation head Z1 and Z2, Z1 and Z2 are equal. So let me just write it properly. So point 1, point 2. Okay, point 1. P atmosphere plus the height of the water column out here. Plus H1 plus the elevation head, which we take to be 0 if you take the datum to be at exactly this point, plus the velocity head, v1 square by 2g, is equal to 1 at point 2, P atmosphere by rho g plus H2 plus 0 plus v2 square by 2g. So H1 minus H2 is equal to 1 by 2g v2 square minus v1 square. Okay, see, now v2 is much greater than v1. So due to this, h1 and h1 minus h2 is a positive value. So h1 will be greater than h2. So the area out here is very less compared to the area out here. So why am I saying this? Because there's a correction. There's a correction applied here. Okay, we'll know it later. So that's why it will be used in the equation of flow rate. So to calculate the flow rate, the formula is C into L into H to the power 3 by 2. Take care that this thing, everything, this is an empirical equation. So use everything in imperial units. Q will be in cubic feet per second. L will be in feet and H will be in feet. Okay. I'll explain what are L and H. Okay. So this is a weir. So if we come back to the weir, I'll take plan view of this, a section view of this way. Okay, and I'll show you how it looks like a section view this way. Right? Yeah, this way. Yeah. So this is how it looks in the in the elevation in the other side, the y-axis. This is a river channel, and this is the weir. This is a rectangular weir. Okay, there can be other weirs too. They can be triangular weirs, but in our case, we'll just concentrate on the rectangular. So Q equal to, let me make both the diagrams. Okay. So L is Q equal to C L dash. It's not exactly L, it's L dash. Q, so C L H. L is this. This is L, and H is this. The height of L is the length of this weir, the width of the weir, of the open part of the weir, this part. And H is the height of the water surface above the height of the weir. Basically, if this is the water surface, H is this much. Wait, no, sorry. H is this much. Yeah, H is this. Sorry, it won't be like this. If you just like this, then you can something wrong. This flat. The water surface will be like this. There is enough control in the flow. So this is H. Okay, and so, but also there's this is the actual formula in ideal conditions. But again, as we keep doing it, basically there were some corrections that are applied due to the, like in orifice, there was some correction applied because of the change in the width of the flow channel while it goes through the orifice. So here too, we'll make some corrections due to some loss of energy that takes place. The first correction is to the length. L is actually L dash. L is actually the actual length L dash. Okay, L dash. Let me not confuse you guys. Okay. Instead of L, you put L dash, which is the length minus 0.1 into N into H. Okay. Now what is N and what is H? So basically, this is a channel. To make it simple, this is the river bank. Now, before this weir was out here, this water was flowing freely through this whole area. Let me show you. Okay, it was flowing freely through this complete area before the weir. See, it was flowing all over the area, but when it came across this weir, it crashed against the walls of this weir, and then changed directions, and then had to undergo a contraction in volume to come and emerge from here. This caused a loss of energy. To account for this loss of energy, we do this L minus 0.1 into N into H. This N accounts for that. So if both the sides, if this weir is on both the sides, if this lengths are on both the side, then N is equal to 2. If suppose this is the channel and it's like this. So in this case, the water is crashing on only this vertical wall. So it has to and there's just one obstruction. So here, N is equal to 1. And if the weir is completely like this, it's just an obstruction, then N is 0. Okay. This part is called, channel width. So if L is equal to B, then N is equal to 0 basically. Okay. And what's the value of C is C is equal to 3.27 plus 0.4 into H over P. You know what is H? P is the height of the crest above channel. But all these values are in imperial units, so this is also phi. Okay. So what does this mean? So in our problem, this cross section of the weir will be like this. It's called, you'll find it in your homework. It's mentioned as a sharp crested weir. So P is this, the height of the maximum height of the distance of the weir, basically. Okay. All right. So this is how you solve the question, and I'll give you a problem. Wait, it's 350. Sorry. So, okay, we don't have time for the problem. You can see this question is in the handout. Let me just solve it for you. Example 5.3. Read the question and I'll solve it quickly. Okay. Let me try solving it. First, I'll make the diagram. Okay. So what did it say? The crest elevation is 282. So this is 282. So E is 282. Okay. Weird, whatever. I don't know. Sorry for that. I'll go back to this. Okay. So what did it say? This height is actually 2.85 feet. So P is 2.85. This is 5.33 feet. Impoundment elevation 283.75. What is impound? Okay. Impoundment elevation is the water level. So this much is 283.75. It's not exactly this. It's basically the actual height. 283.75 is its actual elevation from Z, from the value Z, from mean sea level. Yeah, that's how you say it. From mean sea level, the height of the water column is 283.75. That's how you understand. This is 282. Okay. So from that equation, what is H? H is 283.75 minus 282, which is 1.75. Okay. Now it is double this thing, so n is equal to 2. So n dash is L minus 0.1 into n into H. So this is 5.33 minus 0.1 into 2 into 1.75 is 4.98. What is C? 3.27 plus 0.4 into H by P, which is, see it? Oh no, you can't see it. Okay. And it's not telling me. 3.27. So 3.27 plus 0.4 into 1.75 divided by 2.85, which is equal to 3.516. Okay, so Q is C into L dash into H to the power 3 by 2. You put these values, you get the value of 40.5. Okay, now H is in feet. So it is feet to the power 3 by 2. L dash is in L dash is in also feet. So technically it should be feet, it should be feet 1 plus 3 by 1 plus 1.5. So see, this equation is not dimensionally correct. This should be feet cube per second, but then based on this equation, you see that this is a unit of length and this is a unit of length. So this is not dimensionally correct. So this shows that this is not is not a derived equation. It's an empirical equation that they got from engineering structures. So always, so in this cases, you have to be really careful to use the units in which they made this equation. So always use in this part, always use the English units like feet and feet per second and all that. Okay. Okay. So yeah, that's it for today's class. And do you have any questions? Guys, oh wait, stop record.